Following up with the previous lecture where we talked about 5G, the technologies of 5G, the applications, the services provided by 5G, the interaction between 5G and the other verticals. And most importantly, we noticed that 5G is gonna influence many industries, like from agriculture to energy to transportation to education to entertainment to media to industrial companies and so many like those. That's why it's so critical that we ensure the security of 5G and so that if you ensure the security of 5G, automatically you will ensure the security of these systems. And why the security of 5G is more important than the previous generation? Because it's touching each and every aspect of our life. Yes, when I tell you that it's going to be part of so many fields and so many industries. This means that things are serious. Things are going to be devastating if you don't ensure the security of 5G. Then let's see what are the security requirements and what are the security threats and how the new technologies are going to affect the security levels and how to handle those threats or vulnerabilities and how to improve them in 5G. So let's again start from 1G to understand the evolution of mobile network security landscape, starting from 1G, where we have really very simple, basic, intuitive attacks like eavesdropping and fraud attacks. And then with the emergence of the internet and the inclusion of text messaging, we have the spam. We have something called rogue base station. Basically, the rogue base station is related to authentication problem, because in the 2G standard, the base station can authenticate the user, but the user cannot authenticate the base station. So basically, the user gets locked into the closest base station. So the closest one that's transmitting with the maximum amount of power just connects, the user connects with it. So imagine that a fake base station gets closer to the user and transmits larger power, and the user connects with this fake base station. And then all the communication, all the messages, all the content, everything that's being transferred over that base station is going to be accessed by the rogue base station, actually. And this is dangerous spoofing attack. So in 3G, they changed this. They improved it a little bit more. They say we have two-way authentication. We have downlink and uplink. The downlink can authenticate the base station can authenticate the user can authenticate the base station, and we can avoid such attack. But there are also, with the emergence of the internet and the applications and web, we witnessed the new types of attacks and the new types of threats like viruses, spywares, malicious apps, and worms, and many like those. Then with the 4G, we have now the advanced persistent threats, distributed denial of service, mobileware, and the internet and video-driven attacks. With the 5G, since 5G is about connecting all the industries together and includes Internet of Things and massive machine type communication, and so many services and applications that are going to affect our lives and each and every aspect of our routine, then things are gonna be even more serious and more critical. We have the cyber warfare. Now they call it war. Yes, it's no longer, the war is no longer need to be by gun anymore. Yes, if you want to fight, you don't need now gun. You know what you need? You need to be an expert wireless security. That's it. Now you become a soldier. You become a fighter. You become. This is now we have a weapon in our hand, And this weapon is called the network, the internet, the wireless. And the ones who master this weapon, the ones who learn this, they can fight anybody online. They can fight and take. Imagine yourself being able to protect your organization or protect yourself from these threats. Of course, if you don't fight, you will be fought. And I mean, that's reality. If you don't think that you should be expert in this domain, somebody else is becoming expert, and he will take advantage of you and invade you and challenge you and even attack you. So if you are a nice human being not attacking anybody, this doesn't mean that nobody attacks you. So nice human beings means, no, I should learn how this happens. I should be aware of these attacks, and I should be expert, I should be qualified, so that at least, even if I don't want to attack, at least I know how to defend, okay? You cannot defend if you don't understand what's going on. And that's why I'm really like talking to you serious about this course. This course is not a regular normal course. Even I'm not even like putting those videos online, because this is not a normal course. I mean, those things, this course should be life-changing for you, career-changing, alerting some alarms in your head. This is your future. This is where you can be a valuable human being. I mean, who else? I mean, what a beautiful thing that you can defend your company, your country, you understand the attacks and this and that. So it's serious. This course, we cannot cover everything in security. People spend tens of years in security to understand everything and become real experts. So this course within your master degree, we just scratch the surface. Yes, we give you something from everything, but that thing is so little that, I mean, otherwise we cannot finish the course. We can, security by its own now, a PhD program. It's it's a new specialty. It's like a major. So don't underestimate it, and it should be game changer for you, for your life, for your career. So now 5G and beyond 5G security, we have the security issues. The first type is the security issues which were available before even the emergence of 5G. So which means that all the security issues that they were available with the previous networks are going to be applicable and valid with the new emerging 5G network. So you just derivative from the previous generations, from the previous networks. So the second is issues related to the network softwareization. We talked and we mentioned the importance of moving the functionalities of the network from hardware to software, and this can bring some threats, some lapses, some gaps in the security. And due to these new technologies, new security threats are going to emerge. And you need to understand these technologies and understand their threats before anybody else, and then know how to fix them and how to protect them, and how to utilize even these technologies to provide a better secure wireless systems. Then we have the issues related to new technologies, which such as mobile edge networking, software-defined radio, software-defined networking, network function virtualization, and so on. Cloud computing. Those are the key technology, the key core technologies. I'm not speaking here about the radio technologies. And now you have the issues related to new verticals. Okay, what will happen when you bring 5G to the electricity industry? So you mean that if somebody attacks the 5G network and this 5G is connected with an electricity company, the electricity will be cut on a whole city? What will happen? Who can tolerate this? I mean, we should do something about this. We should prevent this. So you mean if we integrate 5G with a factory, an automotive factory, and someone hacks it, the factory will stop and it will not function? I mean, how can we prevent this? How can we stop this? So you mean if we just integrate 5G with the applications and appliances in our business and homes and somebody hacks them, they can destroy our home or destroy our business? And I mean, nobody can accept this. So we need people who are expert in security to come and protect us from these threats. Yes, we agree 5G brings so many advantages, so many benefits, but at the expense of what? At the expense of making everything vulnerable to security, vulnerable to attacks. And we need to protect this, we need to defend this, we cannot tolerate this. So 5G will be vulnerable to attacks that exist in the previous networks. We call them pre-5G attacks, and those attacks are the following: mobileware attacks such as denial of service, botnet, APT, and so on. You have also the physical layer attacks such as jamming, signals, interference, eavesdropping, man in the middle, and we talked about how significant jamming can be, how dangerous jamming can be, because it can really stop your network from functioning properly or serving any more users. And that's so critical. That's alarming for us. We have attacks related to roaming frauds, IP hijacking attacks. We have also rogue base station attacks. I told you, a base station faking a user, making him think that he's connected with a legit, authentic base station. We have the IMSI catcher, IMSI catcher, intercepts mobile phone traffic and tracking location data of mobile phone users. We have attacks via non-3GPP networks such as Wi-Fi, WiMAX, CDMA. Now, see, we gave you examples of these attacks, but you need to really search about these attacks, how people do these attacks, and search two things. First search is how to do this. Second one, how to protect against this, how to defend, how to stop this. This is how you can learn security. So in the course, we introduce you to so many things, but we don't have time to cover everything because we want to give you exposure to all the new technologies and all the new threats, all the new attacks and the methods. So all what you need to become expert is to search those two terms. First term, how to do this, how to implement this. Second, and learn it. Second, how to defend against this, how to stop this, how to protect the system against this. This is how you become a wireless expert, security. Now we have these are the security issues that exist in systems before 5G, and they are inherent in 5G. They are going to be the same. Now we have security because of network softwareization in 5G. And those network softwareization in 5G will introduce new security issues more than the ones that exist in 4G. Example of this, we have the open architecture now introduce more attackers, since now things are being implemented in software and we are using off-the-shelf hardware devices. Those devices are well-known devices, servers and hardwares which are publicly available in the market. So most of the people have knowledge about these devices and they know how they function and they know how they interact with the software. So this makes it easier for the public, for the people, most of the people, to try to hack the systems, because the old systems, they had their own hardware devices that they were not sold in the market so not easy for the public to learn them, understand them, even they don't share information about them. So now you are coming and telling them, use those devices that you used for computer networks, use them in the communication network, and just program them with software. This will bring all the attacks and all the experience of the hackers who are in the computer domain, and they bring it to the communication domain. And that's significant and going to be risky for the network. And therefore, measures should be taken, and security defense approaches should be used and implemented to protect against such attacks. Second point, we have no implicit security due to the lack of know-how. Yes, because now okay, then now I'm dealing with a communication network that previously was like a monopoly. Only few companies, handful companies in the market provide these devices, and nobody knows about them much. And only few people, only the ones who work on these companies, can deal with these devices. So now you need the functionality of these devices to implement them with software. Then you should know how this hardware device functions first, and take that knowledge and then make the software. And then when this becomes public, it becomes public knowledge, and it becomes really a challenging factor in terms of security. We have the software-based system are easy to hack than hardware, as we mentioned before. And no perimeter security or physical security due to virtualization. Okay, now you have virtualized network. All the mobile operators can use the same site, the same hardware, but they can play with their softwares. So, which means if there is an attack on the hardware, all the companies depending on that hardware will be falling, will collapse, they will get hit, and that's really not easy on the companies. So measures should be considered here as well, and protection should be implemented against such kind of threats. We have the fast deployment of virtualized element with omit proper security testing. All these are due to network softwarization, moving from hardware to software. So new technologies introducing new vulnerabilities, as we said, and those technologies are going to be the software-defined networking, the network function virtualization, multi-access edge computing, and network slicing. So software-defined networking, what's software-defined networking? In the old days, each switch or a communication device has its own control plane and data plane. So basically the control plane is side information that you use it to communicate with the devices, to let them know about the parameters you use in your communication. And so each device has its own control and its own data. Now in software-defined radio, to reduce the complexity and make the network more efficient, you take off this control plane and put it in a centralized controller, and just the device will be left off with just the data, and this control information will be controlled by a centralized unit. So in summary, software-defined networking can be summarized as follows. It's the physical separation of the network control plane from the forwarding data plane, and where a control plane controls several devices. So this is software-defined networking, and the security issues related to software-defined networks are listed as follows. First, the centralized controller is a potential single point of attack and failure. Just think with me, if an attack was able to just take control over this controller, what will happen to the network? The network will collapse. The network will be down ultimately, because it depends, the whole communication depends on this controller. So single point of failure. Some interfaces, like the southbound interface, which is located here for the voice over IP. So and the data forwarding devices is vulnerable to threats that could degrade the availability, performance, and integrity of the network. 3. Hackers can install compromised applications on the controller via the interface number 3, which is called northbound interface. So they can install softwares, applications that are malicious, and they can take control over the controller, which means that they can play with the network the way they like if they manage to do this. Fourth, we have controllers applications are built on general purpose computing platform. Like you are going to use maybe Google Cloud, Amazon Cloud, Azure Cloud for Microsoft. So basically those platforms, they already have their own vulnerabilities. So you are taking the vulnerability of the platform to the network by just using these things. Fifth, you have the forged and or fake traffic flows to overload the data plane switches, because this can happen in the network as well because of the software defined net, because of the new technology called SDN. Sixth, you have eavesdrop, modify, or destroy the ongoing data traffic. All these are threats that exist due to software defined networks. So what you can do to protect against this. This is what we are going to learn in the coming slides. Now, the second technology, we talked about SDN now. What about NFV, Network Function Virtualization? What's this? So basically think of this like VMware on your that you install in your PC, yes? If you want to run different applications that are designed for different operating systems, so you basically install VMware hypervised on your PC, and you just on one hardware, one PC, one laptop, you use different operating systems that can run their own applications. So the same thing here happens to the communication networks, wireless communication networks. You have the hardware, the dedicated hardware devices. You are replacing them with just off-the-shelf standard servers, storage, switches devices, which are available in the market publicly. And then you install virtual appliances over them that can run certain specific softwares to do the functionalities of the old hardwares. So, which means that in summary, network function virtualization is a concept of transforming the hardware-based network functions into software or virtual functions. The goal is to separate network functions from the underlying dedicated hardware, or they can run on standard hardware. Such software-based network virtualized is called VNF, Virtual Network Function. So this picture here you can see is very explanatory, where you can notice that we replace those old hardware devices with normal devices that can do certain functionalities, and the specific tasks that these old devices, old hardware devices were doing can be replaced with softwares. And this brings some security issues. Example, attacks on MANO, malicious, which means malicious misconfiguration, excessive log attacks, log leak attacks, privilege escalation, steal data from storage, and so on. So you have attacks on VNF's interoperability issue, denial service, software flaws, VM escape attack, VNF manipulation attack, VNF location shift attack, and so on. You have also attacks on VMs, the virtual machine itself, VM migration attacks, side channel attacks, scheduler attacks, lack of isolation. All these can happen. Attacks on the hypervisor as well. The guest operating system manipulation, isolation failure risk, exhausting hypervisor, exceeding logs, troubleshooting failure, and so on. You have also attacks on physical hardware, disk failure, physical attacks, code execution on the physical host, state manipulation attack, resource interference attack. All these are things happening due to this softwareization process. Network function virtualization. Third technology is multi-access edge computing. So suppose you want to request a video on YouTube. Should you always go all the way around until you reach the server in USA or the servers in Frankfurt? Why cannot you get the video from the nearest space station to you so that the internet can become faster, the throughput faster, the delay is lower? So this is the new concept called multi-access edge computing, where you move the content, you move the processing, you move the important things very close to the radio access so that the user can get this with a very low latency. And the way to do this is the need to install some semi-data centers near the base stations and move some of the functionalities of the cloud to be within the base station itself. So this is mobile edge computing, as the name implies. Why is that important? Why do we need? Because we have virtual reality, augmented reality applications. Those applications are very sensitive to delay. To overcome the problem of delay, we need to make sure that the response is fast when we are serving the user. How can you make sure the response is fast? By making the content closer to the user. Not only for virtual reality, not only for augmented reality, mixed reality, virtual reality, but also you have big data applications that depend on data, Internet of Things, massive machine type communication, social internet. All these require low latency with very high speed internet. You can achieve this with mobile edge computing and caching. Caching is a technology where if you request a video or a content for the first time, it just takes this video from the cloud and store it where? Near the base station, so that if you request it in the future, it's ready, and if somebody else requests it, it's there now. That's why the video that's being watched in YouTube, let's say more than million times, usually becomes really very fast and in loading from any location around the world. But for videos that are not popular, or you are on a website different than YouTube or some, you notice that there is a delay. And the reason for that, because either the video is not consumed much, or there is no edge computing, and the data center is very far from the location of the end user. So in general, the benefits are providing ultra low latency, locational awareness, and proximity data outsourcing, improved capacity at the edge, and higher bandwidth, along with real-time responsiveness. Why security is important for mobile edge? Edge is the weakest ingress point to the originated services in the RAN. Credibility of Internet of Things devices, weak embedded encryption, encoding schemes due to the market competition. Decentralization of mobile edge computing nodes and moving the data to the close proximity are increasing the probability of exploitation, because now they are not in the data center. The base station and the resources there and the people monitoring this and administrating that site have full control on the data now. Service embedding attacks, denial of service, distributed denial of service, privacy, integrity, and trust management, security of virtualization. All these are contributing to the importance of security in mobile edge computing. And this is the architecture of how the edge is derived from the core, and to make the data closer to the end user. And those are the threat vectors, the different threats that exist due to mobile edge networking. Imagine as if you are creating a new field here. new security field. Because of this new technology, see how many attacks and hacks and interfaces and security measures you need to consider and take into account while you are building your network. And those threats depend usually on the interface. For example, you have interface A1, A2, A3 between A1 between the user equipment and the base station, A2 between the user equipments with each other, A3 is with user equipment with a third party. So in this case, and those are examples of applications that are going to be affected by A1, A2, A3. So now what are the attacks? In this case, the attacks are going to be viruses, worms, which is conventional, well known, wormhole attacks, privilege escalation, impersonation attacks, denial of service, advanced persistent threats, side channel attacks, hardware Trojan, SMARF, distributed DDoS, reduction of quality attack, physical damage, replay attacks, man in the middle, denial of sleep, sinkholes, spoofing, malicious node injection, cyber attack. All these are examples of attacks that can exist on those interfaces A1, A3, A2. So those are the main attacks. So A3 is responsible for third-party applications installed on the mobile. And you need to protect against all of those. You have threat vectors E1, E2, E3, E4, E5, up to E6. Also, they introduce new types of attacks. You have the C1 to C6. Those are new interfaces, and they introduce also a new set of attacks. And imagine the number of attacks that are just because of introducing one single technology called mobile edge computing. So it's so important that you come up with expert people who can come up with algorithms and techniques and methods that can defend the network against these attacks. Now, the fourth technology is network slicing. And what network slicing is, it's basically the separation of multiple virtual networks that operate on the same physical hardware for different application services. So basically you have one infrastructure, okay, and you make different networks, virtual networks, okay. Each one of these networks is dedicated to serve certain area or certain domain or for certain purpose. Like you have virtual network, a slice of the network for broadband, one for healthcare, one for Internet of Things, one for ultra reliable low latency communication. So all of them are using the same hardware, but you change their configuration with the software based on the requirements of the industry they serve. And this is what we mean by slicing, separation of multiple virtual networks. This separation can happen in software using the same physical hardware. So all of them use the same hardware, but for different purposes, which require different applications, different services, and different requirements. So in summary, you just tune the software to meet the requirements of the area or domain or like the organization you want to serve. Attacks related to this network slicing, we have side channel attacks across slices due to different security protocols or policies in different slices. We have impersonation attacks against network slice instance within an operator network. Denial of service to other slices by exhausting network resources. It's well known, this attack. It's happening to all the layers with all the technologies. Even with the OSI layers, we said that this attack, denial of service, happens at all the layers. It's the same here, happening for all the technologies. And last, stealing information from slices when the user equipment is attached to several slices. So those are basically the attacks, and with this we can see that we covered now the 4 key pillar core 5G technologies and their security threats, and this can show us that they are vulnerable and we need methods to handle this. Now we can stop here for this lecture and we can continue in this next lecture with the security issues related to new verticals. So thank you very much everybody for being with us today, and I hope you enjoyed the lecture and you benefited a lot from it and you have learned something new that's useful and beneficial, and you are going to make use of it in the future to protect the future coming 5G networks.